Hey there, this is a really hot topic. It's burning fossil fuels. Let's have a look at fossil fuel combustion to start off with. Fossil fuels are the term given to oil, coal and natural gas. All can be used as independent fuel sources or to generate electricity. When are they combusted? Oil in the form of petrol is combusted or burned in cars. Natural gas can be used to heat our stoves when cooking. All types of fossil fuel combustion release CO2 as a byproduct. Balance. The carbon cycle is said to be in equilibrium or balance between its stores and sinks. Since industrialisation, which was in the 1800s in the UK, but later in emerging and developing countries, the combustion of fossil fuels has increased. As a result, the concentration of atmospheric CO2 has also increased. This has been linked to increases in global temperatures due to enhancing the greenhouse effect. Impact on climate. Globally, high levels of atmospheric CO2 increase global temperatures. Locally, the impacts vary. Eastern and Northern Europe are expected to see warmer winters, while Southern Europe is projected to see warmer summers. Northern Europe see an increase in precipitation, while Southern Europe is projected to see less precipitation. This will decrease water availability and increase the likelihood of drought and forest fires in Southern Europe. Extreme weather events. With the changes in temperature and precipitation, it is likely that extreme weather events will increase. For example, the likelihood that sea surface temperature will reach 27 degrees C for 3 consecutive weeks, which is a prerequisite for tropical storms, will increase, and the area where this is possible will increase. Therefore, the areas hit by tropical storms will increase, as well as their intensity. Let's quickly recap that. What do all types of fossil fuel combustion release as a byproduct? The correct answer is carbon dioxide, CO2. What are the prerequisites of a tropical storm forming? It's a sea surface temperature of 27 degrees Celsius for 3 consecutive weeks. And this is more likely as climate change means a rise in temperatures in certain areas. Now let's have a look at the impact on the Arctic. While warming is noted globally, the Arctic is warming at twice the rate. This is known as Arctic amplification. The effect on the permafrost is that warmer temperatures in the Arctic cause more permafrost to thaw, which releases the stored carbon dioxide and CH4, methane. This leads to more greenhouse gases impacting the greenhouse effect, rising global temperatures and causing more permafrost to thaw. Some studies now show that the carbon may remain in the new vegetation that is able to grow now the permafrost is thawed. This new plant growth may allow carbon to be stored via photosynthesis. Snow and ice changes. Sea ice melts and snow cover is reduced with increasing temperatures. This reduces the albedo effect, allowing more solar radiation to be absorbed by the Earth and resulting in an even greater increase in the temperature. The change in habitat is devastating for the ecosystem dependent on it. For example, the native Arctic fox must compete for food now and territory with the red fox from Alaska, which has migrated north into now habitable land. Let's quickly recap that. So here are some of the different snow and ice changes. It's difficult for ecosystems to adapt to snow cover reducing. The albedo effect decreasing causes more radiation to be absorbed. Snow cover is reduced with increasing temperatures, and the albedo effect is reduced as snow cover decreases. Some studies now show that permafrost thawing is allowing new vegetation to grow. This new plant growth may allow carbon to be stored via what? The correct answer is via photosynthesis. Now let's take a look at the impact on the hydrological cycle. Precipitation rates and the effects of glacial melt are expected to change with global warming. This will result in changes to river discharges and flooding. Precipitation. If precipitation falls with rain and not snow in winter, winter floods can be expected. Summer droughts and forest fires will be increasingly common. Glacial meltwater. As glaciers retreat, meaning that they melt more than they form each year, there will be an increase in river discharge and sediment yields until glaciers have completely gone. Currently, European countries receive water during the summer months from alpine glacial meltwater. Ice in the Western Alps and none in the Eastern Alps by 2100. This will have knock-on impact on river discharge. So let's quickly recap that. What are the different effects of glaciers retreating in Europe? There will be no ice in the Eastern Alps by 2100, impacts on river discharge everywhere, and limited ice in the Western Alps by 2100. Precipitation rates and the effects of global melt are expected to change with global warming. This will result in changes to river discharges and flooding. Eastern and Northern Europe are expected to see warmer winters, while Southern Europe is projected to see warmer summers. What do we call the rapid rate at which the Arctic is warming? We call this Arctic amplification. Snow and ice melt is devastating for the ecosystem dependent on it. The native Arctic fox must now compete for food and territory with which kind of fox from Alaska, which has migrated north into the now habitable land? Correct answer is the red fox.